Hey, TJ Chambers here with smokescreendesign.com again, and I'm actually doing a video. See, I came across one by Red's Rhetoric that says Jeranism Flat Wrong Part 1, and there's something that I've thought about that really stood out to me that I wanted to cover and discuss. I've heard so many times people say that you can create a formula that will prove whatever you want it to prove. And so I thought about that, and I thought about that, and I thought about that. And I kept thinking about this formula in here. And so I thought, I wonder if Red's Rhetoric, this guy says that he proves this wrong, but I wonder if he actually proves it right. So what I'm going to do is a mix of play some of his video, going to go through his formula, and I'm going to show you that when he says he proves Jeranism wrong, actually he proves him correct. And it all depends on what reality is. So that's the only thing that can prove who is right and who's wrong, but you'll see how actually they're both correct. So let's get started with this. And I just went ahead and fast forward. This is around 7:45 minutes, and we're going to take a look at what he's saying.
Your line of sight with the object, and using parallax to find out how far something is nothing more than trigonometry.
So we're going to use trigonometry. I've got a formula set up for that right here. I'm just going to punch in the numbers, and it's going to give us the information. So basically, between 2 points and up to the moon, we're going to measure how far the moon is. So what did Jeranism say? Jeranism said that the moon is, here it is right here,
Miles away, which, by the way, is the next thing we're going to debunk. You said, and I quote, the moon is 100% only 3,000 miles away. Now one would be perfectly justified in asking where the hell you're getting this information from. Another would be, have you ever tried to figure out the moon's distance for yourself?
Okay, you ready? Because we're going to figure out the moon's distance for ourselves using trigonometry, which he says works.
Guessing the answer to that last question is no, and the answer to the first question is, well, we're actually going to leave that one alone. Now the way we can find the moon's distance from the Earth is by using parallax. Parallax is why nearby objects appear to move more than farther ones when moving perpendicular to your line of sight with the object. And using parallax to find out how far something is nothing more than trigonometry. If you wish to find out how far away something is, all you have to do is follow this formula, and we will use this formula to find out how far away the moon is from the Earth. Now the way we're going to do this is that YouTube user Jade, aka Turkey Cat, who's located in California, will be measuring the angle at which she sees the moon relative to the horizon. She will do this edge-on with my location in Florida, and I will do the same while being edge-on with her location in California. However, the first thing we need to do is find the distance between us. Lucky for us, the distance between us is known by, you guessed it, using the fucking ruler tool on Google Earth. With that, we now have the value of D, which is 2,351.81 miles.
Okay, so we need to take this 2,351.81, 2,351.81. Okay, 2,351.81. Okay, so just round it up to 82.
Now what we need is the angle at which we both see the moon. And here are the results. Jade makes her measurements and finds the moon to be 55.4 degrees from the horizon.
Okay, she sees the moon at 55.4. I'm going to put that right here, and I'm going to show you why in a little bit.
These measurements were done when I found the moon to be directly overhead at 90 degrees edge-on with Jade's location in California.
Okay, so his is 90 degrees. So we've got degree number 1, 90, and we've got her degree 55.4. So let's keep going.
With these values now accounted for, there is one more thing we need to take into consideration: the curvature of the Earth. Yes, that same curve that made the ship disappear from our line.
By the way, I did a video on this ship. This is complete horse shit. Red's rhetoric. I can't believe you got fooled by this dumb-ass video.
Of sight.
Oh my gosh, this video fakes so many people. Just watch my video on the ancient ship and just whatever. This doesn't prove nothing.
Seen previously. You see, as you get further away from a point on the Earth, the more deviation you will get in your visual angles. For example, if...
Now, I just want to make a point right here. If we're on the curved Earth, which, fine, let's say we're on a curved Earth, why is it when we fly, whatever, we don't ever see buildings leaning away from each other like this? And they have to, because certain parts of the Earth are curved away from others. So at some point when we're on a plane or we're on, some type of ISS, space station, when we're on something, at some point we've got to be able to see buildings that are curved away from each other. But we never, ever see that.
If Jade were to look straight up in California, and I were to do the same in Florida, we would not be looking in the same direction. There is a deviation there caused by the curvature of the Earth. How do we correct for this? Simple. A complete circle is 360 degrees. So if we divide the circumference of the Earth by 360, we will get 69.169 miles per degree of change. Now, if we take the distance between our two observers and divide it by that number, the miles per degree of change, we find that our visual degree difference is 34 degrees. So what this means is that we will need to add 34 degrees to Jade's measurements in order to offset the difference.
Okay, so we need to offset the difference for the curvature of the Earth. So we're going to look at two ways. One is the Earth is flat. Doesn't mean a pancake. You look with your eyes, you see that there are dimensions up and down to the Earth. We need to make note here for curvature of the Earth, and we're going to do that. But what if the Earth is flat? If it's flat, then we don't need to do this. So we're going to see what the two differences. Remember, Jeranism said it's only about 3,000 miles away. And this guy says it's horse shit. If you use trigonometry, you'll see that is wrong. So let's find out.
Which, when we do the simple math, gives us a new value for Jade's observations.
So now Jade's observation, which she saw, was 55.4, right? 55.4. Like, nope, sorry, the Earth is curved. We gotta add 89.4 degrees. So we have to make it to where I'm at 90 degrees and you're at 90 degrees, shy of 0.6. Let's keep going.
Value is 89.4 degrees. This means we can now find our parallax. Now the inner angles of any triangle will always equal 180 degrees.
Okay, so he brings us up that the angles in a triangle will add up to 180 degrees. So here we have angle 1. My formula up here up top. Let me pull this down a little bit. So you see that there's no formula in this box. Next box, no formula. And then this box, what I'm doing is we're taking 180 minus C26, which is this first angle, and then C27, which is the next angle, and it's going to give us the third degree, which is not masonry, but it's the third degree of the angle. So it's going to do this subtraction for us. Now what also is going to happen, down here we have more of the formula. So C25, so it's going to take the distance, which is C25 right here, and then it's going to take the tangent and the parallax, and it's going to give us the miles. So we're going to see that here in a little bit.
We simply minus the total degrees we observed from 180 degrees, which gives us a parallax value of 0.
Okay, 0.6. Let's get that over here. 0.6 is what he says, but it's actually 89.4. So what I'm going to do is put in 89.4 here. So these are the 2 degrees we're going to play with.
0.6 degrees. And finally, we now have everything we need for our equation to solve for x. So x will represent the distance from the moon to my location in Florida. So we simply plug in the values where they belong, crunch them out, and what do you fucking know? We found that the moon is 224,573.102 miles from my front door.
Okay, so it's 224,573 miles. Okay, so let's see what we get. Let's plug in 89.4 because we had to account for Earth's curvature, and forgot that there we go. So we have to account for Earth's curvature, which gives us a parallax of 0.6, which makes this 224,573.1. Is that right? 224,573? 224,573.1. Okay, so this formula works. But what if the Earth is flat and we put in 55.4 for this degree? We go back to her original degree that she had because we say, all right, what if the Earth is flat? That's what journalism says. Oh, wait a second. Now the moon is 3,409.143 miles away. So let me just ask you a question. Does the moon look like it is 3,409 miles away? Or do you think it looks like it's 224,500 miles away? Because if the moon really looks like it's 3,400 miles away, then based on what he just showed us, the Earth is flat. But if the moon looks 224,000 miles away, then the Earth is a sphere. Now, go look at amateur cameras that people sent up in a balloon. Look how close the sun looks. Look at how it's over the Earth. Look at the hot spot below. The sun does not look 93 million miles away. I know I just jumped to the sun because I haven't seen people really show the moon yet because they always do these flights during the day. But the sun, people that talk about the flat Earth say the sun and the moon are about the same distance up, roughly around 3,000 miles away. So if you can see that the sun looks 3,000 miles away, then the moon probably also is about that distance. Use your own observation. Let's see what the ending is here.
The conclusion is that your assertion that the moon is only 3,000 miles away is horseshit. So, Duranus.
So, I've got to ask you, based on the formula, is it 3,000 miles away? Or is it 220 whatever thousand miles away? Because he seems to think that he's absolutely correct, but I've just proven that, well, if the Earth is flat, it says that it is 3,000 miles away, and he's wrong. So you just got to make the decision. Formulas will tell a different story depending on what the reality is.
What have we learned here today? We learned that we can in fact see farther than what your equations will allow. We learned why objects do in fact disappear.
So that's I'm ending the video here. I've got the spreadsheet that I'm updating, and at my website smokescreendesign.com make this available for you to download to where you can use it and plug in. Got the curvature of the Earth, so at 1 mile it's 8 inches of curve. 10 miles we have 67 feet of curve. Then over here, this is for the horizon, and what this is basically the distance that you should be able to see your line of sight to the horizon. So if you're 6 feet, and it all also depends on, there's some variables like the moisture, humidity, atmosphere, all those things can block your line of sight. But if your eyesight is about eye level, say 6 feet high, roughly, then you'll see about 3 miles out. So the horizon you see is about 3 miles out. If you're 5 feet, roughly 2.73, 2.74 miles. And I just have some different formulas here, just seeing how they differ. This is supposed to be the short, simple one. It's supposed to be a little more complex one. And so I'm still working on more. Pretty soon I'll have this on my website where you just go in and punch numbers there and you won't have to download a spreadsheet. Okay? Thanks for listening, and definitely leave some comments.